Hello, everybody. Welcome to another lesson in probability. Today, we'll look at the discrete probability distribution. This is the table formula that lists the probabilities for each outcome of the random variable x. Right. Okay. When we say a random variable, we just mean a set of all possible outcomes from an experiment, right? And these outcomes can take any value. That's why it's called a random variable. And when we say this word discrete, it means numbers which are whole numbers like this 6, 7, 8. We're not dealing with numbers like 8.09, maybe 8.001. No, we just want whole numbers, not decimal places. All right. So let's look at this example here. The table shows the probabilities for the number of complaints received each day by an agency. So our random variable is the number of complaints. Okay. And here are the probabilities for each of the values. All right. And we've been told first to find the mean and the standard deviation. And we'll find the cost of they've told us that the cost of complaints in Quacha is given by this function here, C equals 400 plus 100x. We have to find the mean and standard deviation of the cost of daily complaints. And then we also have to show this as a probability mass function. So let us begin. First, we find the mean. The mean is also called the expected value. Other questions they'll ask you to find the expected value. And so this is how you find the expected value. This is the formula. Let me write the formula first. Expected value for the random variable x is equal to right. So basically, to get our expected value, each random variable we're going to multiply it with its probability. All right. So we're going to say equals. So we say 6 times 0.25 plus 7 times 0.25 plus 8 times 0.5. So let me get my calculator. 6 times 0.25, that's 1.5 plus 7 times 0.25, that's 1.75 plus 8 times 0.5, that is 4. So 1.5 plus 1.75 plus 4, you get 7.25. So that is our mean or our expected value. The next thing that we'll find is our standard deviation. So to get our standard deviation, must first find our variance, all right? And this is how we find our variance. The formula, variance equals Right, so this is the formula to get our variance. Right, so this x squared is the same as getting our expected value. The only difference is our random variable x, we are going to square it. We're going to square our random variable x and then multiply it by its attached probability. All right, so this formula can be simplified to this. Okay, we're going to square our random variables and then multiply them by each of the probabilities of our variance. So here basically I'm just simplifying the formula. Oops. Yes. Yes, and then we're going to subtract it from our expected value. All right, we're going to square our expected value. All right, so this is how it goes. Let me just copy these two here. Right, so it's going to become 6 squared times 0.25, 7 squared times 0.25, and 8 squared times 0.5. And then we subtract that from our random variable, but we're going to square it. So 7.25 squared. Let me get my calculator. So 6 squared, that is 36. So we have 36 times 0.25 plus 49. 7 squared is 49. 49 times 0.25 plus 8 squared is 64. So 64 times 0.5. And we get 53.25 minus 7.25 squared. What is 7.25 squared? That is 52.5625. Right. We'll leave our answer to two decimal places. So 53.25 minus 52.5625, you get 0.68. 0.6875. So we just leave it to two decimal places, 0.68. All right. Then to get our standard deviation, all right, we have to find the square root of our variance. All right, so standard deviation is represented by sigma or S, whichever. Standard deviation, okay. Let me just insert the square root. Let me just get the square root from this equation. Symbol. Oh, to get the square root of get the square root of 0.68. So the square root of 0.68 is 0.82. 0.824. 0.82. We leave it to two decimal places. So we are done with part one. We found the mean and the standard deviation. Then they've told us the cost of complaints in Quacha is C equals 400 plus X. So find the mean and standard deviation cost of the daily complaints. So what we're going to do is we're going to replace each value with X into this equation here. So when X equals 6, let's do that. When X equals 6, cost, so it's a 400 plus 100 times 6, right? So 100 times 6 is 600. 400 plus 600, that is 1000. And X equals 7. That is 100 times 7, that's 700. 700 plus 400, that's 1100. Then when X equals 8, 100 times 8, that's 800. 800 plus 400, that's 1200. Now, since we've got the costs, these costs, we're going to multiply them with each of the probabilities, all right? The costs, we're going to multiply them by these probabilities, all right? So again, the one they told us to find the mean and standard deviation of the costs. So again, we use this same formula, only this time our X will be replaced with our new values, which have tabulated when we put our random variables into this equation. So this is what we're going to do. All right, so this 1000 multiplied by the probability which was attached to our random variable for 6. So it's 1000 times 0.25 plus, and we'll say 1100. The probability which was attached with 7 was also 0.25. So 1100 times 0.25 plus 1200 times 0.5. So we get our calculators. 1000 times 0.25 plus 1100 times 0.25 again plus 1200 times zero point 0.5. So this is our mean cost, 1125. Okay, then again we have to find the variance cost. So again we use this formula. All right, so again we're going to square each of these. Let me just get this down. So basically we're just repeating the process again. Right, so we'll have 1000 squared times 0.25 of 1100 squared times 0.25. Then we have 1200 squared times 0.5. And then we subtract it from our mean cost and we'll square our mean cost. So we say minus 1125 squared. Right, so let's do it. So 1000 squared 0.25 plus 1100 squared times 0.25 plus 1200 squared times 0.5. We are going to get 1,272,500. Right. I've got this after I've added everything. Okay. After adding everything that I've highlighted. Minus, okay, so we'll say 1,125 squared to get 1,265,625. Our variance cost. So 1,272,500. minus 1,265,625. We get 6,875. All right, and then to get our standard deviation, just get the square root of 6,725. That gives us 82.9 kwacha. 2.91 kwacha. Okay. Then they've told us show this as a probability mass function. Okay, so also a probability mass function just shows the probabilities of each random variable. All right, probabilities of each random variable. Okay, so let me write that down on the board. Let me write the probability mass function. Let me see what symbol I can use for this. Probability mass function. Oh yeah, can use this. Right. So for the probability of 0.25, that's when x equals 6. The probability of 0.25, okay, that's when x equals 7, or that's when x equals 7 or 6 or 7. So I'm saying x equals 6 and 7, right? The probability of 0.5, oops, x equals 8, right? And we put here it's more neat like this, yeah. And and when put here 0 and say otherwise. So the otherwise, what it means is if X is any value apart from 6, 7, or 8, the probability of getting it is 0, right? The probability of getting it is 0, all right? That's what this otherwise means. If X was, let's say if X was 5, and our probability distribution table, we don't have it there. We don't have any value of 5, 4, or maybe 9, 10. So probabilities of other values apart from 6, 7, and 8 are 0. All right. Then I was supposed to put a sign for a bracket here, but this is our probability mass function. So thank you guys, and we'll see you next time.